All right, so the last thing we have in Unit 8 is Lesson 5. Again, it was a very short unit. We have a new symbol, and it's the Greek letter, and this is the Greek letter, and it is called sigma. It's the capital letter of that, which is also small sigma. But what you need to learn about this big E is it means to sum up. And down here I have a snapshot of a Microsoft Excel page. And there it is right there. It says Auto Sum. So you can press this key in a Microsoft Excel and it will automatically add up whatever column or row you're in. So it has some parts here. I'm going to move that over here. This is what it's going to look like. There are actually 4 parts to this. We start here on the bottom. This is your first step. This is your index. There's going to be a number here, and that number tells you where you're going to start. This is step number 2. This tells you what number you're going to end at. And then here is going to be a function or an equation. And what you're going to do is put in one number at a time, get an answer, and you're going to stop wherever they told you to stop. So what you'll have is a bunch of numbers, creating a sequence, but we're going to create a series because the last thing is what we just learned. This big E right here, well, that's telling us to add up all the answers we just got. So all these numbers we just got, we add up and we get a sum. So for example 1, this is what we have. The index says we're starting with -1. Every time we see a K, we're going to put in a -1. There's a K. And for the K, I'm going to put a -1, and they want me to square it. After -1 comes the number 0. I'm going to put 0 in. I'm going to square it. After 0 comes the number 1. I'm going to put 1 in. I'm going to square it. I'm going to put 2 in. I'm going to square it. See, I'm just counting. And where am I going to end? Well, they told me to end at the number 3. So I'm going to put a 3 in, and I'm going to square it. Now notice I put plus signs in the middle because that's what the big E tells us to do. The big E tells us to add all these answers up. That's the answer of 1, that's the answer of 0, that's the answer of 1, that's the answer of 4, that's the answer of 9. And when I add them all up, 9 plus 1 is 10, plus 5 more. Boom! When I summed up all my terms, I got the number 15. All right, so this one, same thing. Notice this is the letter I. This was the letter K. You can use any variable you want as long as they match in the equation in your index. All right, so they're telling me to start at 1. Every time I see an I, I'm going to put in 1. All right, now I'm going to add on to that. Well, I'm going to go to 2. Then they're telling me to put in 3. And they want me to end here at 4. All right, so now the big E tells me that I take every answer I got and add it up. This isn't hard. 1/2 plus 1/4 is 3/4. Now I'm going to add on the 1/3. I'm going to use my little shortcut of how to find a common denominator. Multiply across to get 12. Multiply up to get 9. There's a plus in the middle. Multiply across over there to get 4. So those added to 13 over 12, but I still had that 1. So no, the answer is not 1 and 13/12. The answer is 2 and 1/12. And if you can't change that into that, we got issues. All right, the last problems. They are going to ask you to create this sigma notation. Ruh-roh. Well, first thing I have to do is look at my series that I have here, and I have to try and write a formula for it. Now, we just spent 2 days doing arithmetic and geometric sequences. So that's the first thing I'm going to check. Is this an arithmetic series? 9 plus 7 would get me 16, but 16 plus 7 doesn't get me 25. Ooh, 9 times what gets me 16? Well, 9 times what gets me 16? R is 16 over 9. Does 16 times 16 over 9 get me 25? No, nowhere near it. So now I have to think. Well, look at the numbers. 9, 16, 25, 100. Hopefully your brain says, well, they're all perfect squares. Oh, I see it now. They are adding up, so I write the big E, some number squared. Well, what was the first number they started squaring? 3. So that means my first number I'm going to put in is 3. And what's the last number they squared? 10. So I'm going to stop at 10. Now notice the directions said express each sum using sigma notation. It says use I as your index variable. So I'm going to have to come down here and I'm going to actually have to change this x to an I because that's what the directions told me to do. Boom. Okay, last one. I know that they want me to write it in terms of sigma, so I'm going to come right over here, put my sigma, and I'm going to put my I equals, because they said write I as my index variable. Well, what's going on here? What did I do to 1 over 25 to get to 1/5? I don't know. That's too much fractions there. I'm going to look here. What did I do to 1 to get to 5? Well, my first obvious choice is I added 4. But we know that won't work. We know 1/5 plus 4 does not get me 1. Well, let's look at geometric. What did I do to 1 to get to 5? I multiplied by 5. Does that work? Sure does. 1/5 times 5 does indeed get me 1, and 1 over 25 times 5 does indeed get me 1/5. All right. So, this is a geometric sequence. I'm going to take some time and I'm going to come over here and I'm going to figure out the formula. We know to find any term, we start with the first term and multiply by my ratio n minus 1 times. Okay, so to find any term, I start with the first term, which was 1 over 25, and I multiplied by 5 to the n minus 1. Well, that'll work, right? Because if I put a 1 in for this, 1 over 25 times 5, 1 minus 1 is 0, 5 to the 0 power is 1, 1 over 25, right? When I put a 1 in, my first term is indeed 1 over 25. If I put a 2 in, 1 over 25 times 5, 2 minus 1 is 1. And we already know 5 times 1 over 25 is 1/5. All right, so how does this come into our sigma notation? Well, that equation we just figured out, that equation goes right here. We figured out that it was 1 over 25 times 5. Now instead of the n minus 1, they wanted me to use I. So that n is going to get replaced with an I. Now the only thing we have to think about is, well, what term did we go out to? This is the first term, this is the second term, this is the third term, this is the fourth term. Now I could use my geometric series formula again. I'm going to be incredibly lazy. So I know that 5 times 5 would be 25. That would be in my 5th position. Times that by 5 again, that's 125. That would be in my 6th position. And right there in my 7th position, if I multiply 125 times 5, I get that number 625. So I guess I can finish this up now. I'm going to start with the first, and I'm going to end with the 7th term. This sequence will be generated from that summation.